Welcome back to my channel. Today's video features a problem from the 25th Philippine Math Olympiad area stage. Let A, B, C be real numbers with 1 less than A less than B, and B less than C that satisfy the given logarithmic equations. Then the maximum of log of B to the base A, log of C to the base B, and log of A to the base C can be written in the form square root of x plus square root of y, where x and y are positive integers. What is x plus y? Okay, notice that there is a total of 6 unknowns in the system. So what I'll do first is reduce the number of unknowns to make the system easier to handle. The main tool that I'm going to use to do this is the change of base formula. The change of base formula tells us that if we have log of m to the base n, then we can write it as log of m to the base t divided by log of n to the base t. In other words, a logarithm can be written as a quotient of two logarithms of the same base. Now, I'm going to apply the change of base formula to the second equation to come up with an equivalent logarithm for each term in the left-hand side. Let us start with log of a to the base b. Applying the change of base formula, we can write this as log of a divided by log of b. We can further write this as 1 over log of b divided by log of a. Now, if we apply the change of base formula to the denominator in reverse, we will come up with 1 over log of b to the base a. So log of a to the base b is equal to 1 over log of b to the base a. Let us also apply the formula to log of b to the base c. Now, we will come up with 1 over log of c to the base b. Applying the same process to log of c to the base a, we will have 1 over log of a to the base c. Okay, now I can write the second equation into 1 over log of b to the base a plus 1 over log of c to the base b plus 1 over log of a to the base c equals 5. I'm going to simplify further the equations by letting p be equal to log of b to the base a, q be equal to log of c to the base b, and r be equal to log of a to the base c. So the two equations will become p plus q plus r equals 6.5 and 1 over p plus 1 over q plus 1 over r equals 5. Now let us manipulate the second equation. Let us get the LCD and then combine the terms in the left-hand side to get QR plus PR plus PQ all divided by PQR equals 5. Multiplying both sides by PQR and then rearranging the terms in the left-hand side, we will get PQ plus QR plus PR equals 5 PQR. So this is our second equation. Now, I'm gonna suppose that P, Q, and R are the roots of the cubic equation quantity x minus p times quantity x minus q times quantity x minus r equals 0, because if we expand the left-hand side of this cubic equation, we will get x cubed minus quantity p plus q plus r x squared plus quantity pq plus qr plus pr x minus pqr. And notice that it contains expressions that are also present in the given system. So I can replace p plus q plus r by 6.5 and pq plus qr plus pr by 5 pqr. So the cubic equation becomes x cubed minus 6.5 x squared plus 5 pqrx minus pqr equals 0. Now, if we can find the value of PQR, then we can reduce the problem to finding the roots of this cubic equation. So how can we find the value of PQR? Let us consider multiplying PQR. If we do this, we will have log of b to the base a times log of c to the base b times log of a to the base c. And by applying again the change of base formula, we will have log of b divided by log of a times log of c divided by log of b times log of a divided by log of c. And notice that we can actually cancel all of them to get PQR equals 1. So now we can substitute PQR equals 1 in the cubic equation. Now we obtain x cubed minus 6.5x squared plus 5x minus 1 equals 0. Now to make all the numerical coefficients integers, I will multiply both sides by 2. And then we will have 2x cubed minus 13x squared plus 10x minus 2 equals 0. You can easily check by using the rational root theorem or the remainder theorem that x equals 1/2 is a root of this cubic equation. And so if x equals 1/2 is a root, then the left-hand side of this equation can be factored into quantity 2x minus 1 times quantity x squared minus 6x plus 2. Now, to get the roots of x squared minus 6x plus 2, you can just apply the quadratic formula. And so, the three roots that we have are 1/2, 3 plus square root of 7, and 3 minus square root of 7. These are now the values of PQR. And now, we should find or we should determine the maximum value of these three values. So, which one is the maximum? Obviously, the maximum is 3 plus square root of 7. And take note that we are required to write the maximum value in the form square root of x plus square root of y. And obviously, 3 plus square root of 7 is just equivalent to square root of 9 plus square root of 7. And so, the value of x plus y is just 9 plus 7, which is 16. And this is our final answer.